gauge. Under measurements, first let us know about the screw gauge. Okay, screw gauge, it is used to measure the thickness of thin glass plates, right, diameter of wire, or small spheres. Okay, now this screw gauge works on the principle of screw in a nut, right? Now how means, just for an example, I am showing a screw, right? Now this we call it as threadings. We took a metallic cylinder, we also call it as shaft. We did threadings on this cylinder. This end we call it as tip, and this we call it as head. Now this is the nut. Inside the nut also there will be similar threadings. Now by rotating the head, we just insert this screw into the nut. Based on this principle only, screw gauge is designed. Okay, so based on this principle only. So in construction, it consists of a hollow cylinder. This is a hollow cylinder. Inside the cylinder, in such a way, some equidistant threadings are made. Okay, this hollow cylinder acts as the nut. Next, we will take a metallic cylinder. We will make a similar threadings on this cylinder. Okay, this end we call it as tip of the screw, and this end we call it as head of the screw. By rotating this head, we will send this screw into the nut. Nothing but hollow cylinder acting as the nut, right? Now here separately I am drawing the screw. Now these are the required threadings which we made on the screw, right? When we rotate this head of the screw, these enter into the nut, and the distance travelled by this screw we call it as pitch. So pitch means the distance travelled by screw. So this is this distance, this distance, this distance, we call it as pitch. Now next we will draw a straight line on this cylinder. This straight line we call it as index or reference line. Now this reference line is divided into equal divisions, and these divisions we call it as pitch scale, right? Now next, this arrangement is connected to a metallic frame. So I am drawing a metallic frame F. This arrangement, this is the screw, is connected to the metallic frame. Now this we call it as stud. So in between stud and screw only we will place the required object, and if we bring this screw towards the stud only, the object will be fixed perfectly in between these two. In such a way I placed an object. Now if stud is brought towards this object, then this S1 and S2, they will hold the object without falling. They will hold the object perfectly. Now next, so we talked about the reference line, right? Now this is the reference line which I said before, and this is the equal number of divisions. This we call it as pitch scale. Okay. Now next, on this cylinder we will arrange a barrel. Okay, this one, and this is the cylinder. This is the hollow cylinder. Over this cylinder we will arrange a barrel. This barrel is also divided into equal divisions, and this divisions we call it as head scale divisions. This divisions we call it as head scale division. Okay. Now next, this milled head through which we rotate the screw gauge. Okay, these divisions on barrel we call it as head scale divisions. Okay, so this is about the construction of screw gauge. Now the distance travelled by the screw we call it as pitch, right? Now how to calculate the pitch of the screw? The pitch of the screw. So here first we will see the distance travelled by screw by how many rotations we made, the number of complete rotations made. So here we are saying now with the help of head we are rotating the screw, and the screw is entering into the cylinder. So that rotations made, we will see 5 rotations or 10 rotations or we will take, and for that rotations how much distance this screw has travelled, that ratio gives pitch of the screw. Distance travelled by the screw by number of complete rotations. If P is the pitch scale or pitch of the screw, X is the distance travelled by the screw, N is the number of rotations made, then pitch of the screw is written as X by N. Next, least count. Okay. Now least count means the smallest value measured by an instrument, we call it as least count. Such least count is defined as ratio of pitch of the screw by number of head scale divisions. If pitch of the screw is 1 mm, number of head scale divisions is 100 or 50, then the least count comes out to be 1 mm by 100. So that is 0.01 mm or 0.001 centimeter. Next, diameter of a marble or thin wire is measured by using the formula D equal to pitch scale reading plus head scale reading into least count. Okay, pitch scale reading plus head scale reading into least count. Right? Now the main thing which we have to know about the screw gauge is about zero error. Now this is the index line or reference line, right? Now let this be the zero of head scale. If index line or reference line exactly coincides with zero of head scale divisions, then we say that there is no error. But in some screw gauges, index line will not coincide with zero of head scale divisions. Index line will not coincide with zero of head scale division. Now let this be index line, okay, or reference line. Let us assume that 0 is above the index line. 0 of head scale divisions is above the index line. Then we say that negative error has occurred. Okay, if index line wants to coincide with 0, then we have to do minus, then only it comes down and coincides with the reference line. So only such errors we call negative error in screw gauge. Here 0 is above the index line, right? And in calculations we just add the value. Now here see, between index line and 0 two divisions are present. So I can say that, for example, if two divisions are present, I can say that negative error is -2. And in answer we have to add, that is observed HSR plus N, right? So here in answer or the corrected head scale reading, we can say corrected head scale reading is nothing but observed head scale reading plus error. Okay, this is about negative error. Now next, similarly, in some screw gauges 0 will be below the index line. Okay, the 0 of head scale readings or divisions will be below the index line. Okay, such errors we call it as positive error. For example, let us think 2 divisions is below the index line. Then corrected HSR is written as observed HSR minus n. If we get positive error in correction, we have to do negative, that is minus n. If it is negative error in correction, we have to add it. So this is about zero error, positive and negative errors. If index line exactly coincides with 0 of head scale division, there is no error. We call it as zero error. If index line, if 0 is above the index line, we call it as negative error. And if 0 is below the index line, we call it as positive error. So totally, the first formula which we will learn is pitch of the screw, which is nothing but distance travelled by the screw divided by number of complete oscillations. Least count, which is nothing but pitch of the screw divided by number of head scale divisions, and diameter is nothing but pitch scale reading plus head scale reading into least count.